So thank you everyone for joining us today. I'm Tanya Brown in Toronto, Canada, working at the Rotman Research Institute at Baycrest with Dr. Randy McIntosh as the program manager for the virtual brain. For those who are not familiar with TVB, it's an open source neuroinformatics platform for simulating large-scale brain dynamics. And TVB was built by a large international consortium of a multidisciplinary team, first released in 2012, and to date we have more than 30,000 downloads. And as much as I'd love to tell you more about the impressive features and outcomes of TVB, I'm actually here today, or tonight for some of you perhaps, to talk to you about science management, specifically within the domain of neuroscience. And if you're not already convinced of the necessity for management in science, then certainly I aim to convert you into a believer. I'll also share with you some useful resources, some standards and best practices that could help guide you through your own research programs. So I'll begin with a more general focus on project management and then transition into more subdomains, including data management, knowledge translation, science communication, and people and performance issues. So I don't think you need me to tell you that science has changed a lot over the last 50 years. In fact, I'd say a lot over the last 5 years with the increase in the number of different hats that scientists need to wear. And there's an increasing amount of pressure on researchers in terms of funding and publications and collaborations, often not just within our own labs or institutions, but rather on a global scale. Perhaps some KT activities, also battling with data-related issues, always gaining knowledge from other areas that were previously not really even on our radar and beyond. And in 2018, Nature came out with a paper that reported that almost half the PIs that they surveyed declared that they did not have, but would like formal management training. About a quarter of them had some training and thought it was useful. And then there was another remaining proportion that didn't particularly have an interest or shared value in management training. But in fact, I've even received comments along the lines of management stifles science, or it kills the creative spirit of science. And to that, I'd say that then you're probably not doing it right, because science management really does have the power to elevate our practice to a new level when done correctly and in an intentional way. And here in Toronto, I consider myself very fortunate to be working with a team, albeit with Randy and the rest of the TVB team, as regarding this type of approach to science as not only valuable, but it treats it as a requisite to how we conduct our lab and just kind of the greater TVB initiative. And I'm also grateful for the Neuromatch organizers who saw this topic as value for this community, and to those who decided to join us today. So I like this quote because it touches on the point that is often used as a reason for avoiding any type of planning, in that why make a plan if I'm not going to use it? But the nature of project management is not that anything is concrete, but rather it provides a structure to the way that we do our science that imparts a balance between exploration and production, with the built-in capacity to modify it as you go. So some examples of project management in science: I would typically be breaking down projects up into such things such as a study or experiment, or a grant application, or a presentation of some sort, a KT project, kind of your day-to-day administrative tasks, that counts too, managing a collaboration or organizing an event. And central to the formal project management is this project life cycle, and understanding how to carry out each stage here that's listed on the right, with the greatest amount of efficacy, can determine really the success of your project. And in looking at this list, I'd like to invite you to reflect on each and assess whether this is something that you always, or often, or sometimes, or never do as you approach your work. My guess is that it's unlikely that you've typically ever really closed out a project or prepared a comprehensive project plan, as these are not typically expected or required. Although in practice, these things are critical for developing an effective workflow. But when we step back and consider how we measure success in science, I'd say that we converge on kind of 3 pillars, that being time, such as the turnaround in which, say, your study, in the time that it's done, and by the time you get to the end, is it still relevant? The cost, we do have a restricted amount of funding dollars, so we're expected to make deliveries on tight budgets, and scope of whether your study, your project, or your event achieved what you set out to do, or did you lose track somewhere along the way. And kind of with this trifecta of factors is when it's delivered at an appreciable level of quality, in turn, we can really witness the creation of scientific merit. So next, I could make an entire workshop about the various tools available for project management, but here are just a few of my absolute go-tos. The first being a project charter, and this is a master document that contains all the various pieces of planning and managing your documents that will support the project. And this can be tailored to the needs of each project. For instance, if you're working more independently, it's not likely that you're going to need a team management document, but almost always you'll need to have a work breakdown structure or a budget or a resource index. Next up is a Gantt chart. This is probably both your enemy and your friend, as it does require some upfront effort, but the ROI can be exceptional if executed in the right way. And because it's a great way to visualize and track your project, as well as identify problem areas and make adjustments as needed. And when it comes to project managed software, there's a plethora. Oh, sorry, I'll go back. There is lots of options out there, but my recommendation is twofold. It's to pick something that serves the problem you're trying to solve. Don't just use the next hot thing. For example, when Slack came out, everybody wanted to use it for something, and it can be great for team collaboration or communication or getting some sorts of work done, but it performs less well as kind of a project tracking method. I'm quite partial to a software platform called Trello, which does have a freemium version, which is typically sufficient, but it does have an extensive and useful plugin array that allows you to really customize each project board appropriate for the need of a particular project. The other is Git or GitHub for the more technical projects, because there's version control systems that allow you to manage or track your source code. And there's also a niche community within Git that has the potential to open up doors to even potential collaborations. And lastly, my word of advice on this is that there is no tool, at least not yet, that's not going to require your effort and attention to be effective. So pick a platform that A, you will use, B, your team will use if you're working with a team, and C, that it serves the appropriate function that you need it to. And maybe if we get to the Q&A, if anyone has some specific challenges where they're looking for specific resources, I'll be happy to deal with them then. But maybe moving into the next topic or subdomain would be data management, which is a major area of importance and consequence, but so often disregarded. More often than not, I think many researchers are in the mode of kind of making it up as they go and kind of like building a bridge. I like to say of like putting down the board as you're crossing the bridge. Which is both an ineffective way to build a bridge, but similarly, it's hazardous when it comes to big, expensive, and time-consuming data. So research data is rapidly increasing in size, variety, and complexity. Big data does provide lots of opportunities and value, but it does not come without challenges, especially in health and medical research due to some of the regulatory requirements, which adds additional layers of complexity. Research data management is broken up into 3 phases, that being pre, during, and post-research. And with each section, there's a list of factors that you should become familiar with. So just to go into some of the more practical issues to be aware of when it comes to managing your data. First up is standards. So we have several in neuroscience, first being the FAIR principles, and leading some of this is INCF, where we find data that's findable, accessible, interoperable, and usable. There's also CARE, which is a global Indigenous data alliance, as well as OCAP, which is something that we have here in Canada. And this is a set of standards that's established by the First Nations in terms of how data is collected, protected, used, and shared. Of course, we all know BIDs, hopefully, for neuroimaging data, and there are more. But a data management plan, the objective is to address the issues related to data management prior to starting your research project. It's a formal document which clearly articulates the strategies and tools you'll implement to effectively manage your data, and speaks to the management of data both during the active phase of your research as well as at the completion and beyond. And sometimes a data management is required even by funding bodies. This is an increasing trend that we're starting to see. And if it's not required, noting that you have a data management plan in your application can signal to reviewers that you have considered the details for your proposal. Data storage, this is a big one. I won't go into too many of the details, but just knowing that it's something that you should always be mindful of. Knowing the risks related to transferring data and making sure that you prepare accordingly before making any moves. Documentation, which is an absolute must, especially when it comes to code. And to be aware that various publication requirements are out there. For example, PLOS requires data to be open. Moving on to knowledge translation. I think for the purposes of today, I'm only going to be brief, touch on this topic, as it should be understood that even though as researchers that we may not explicitly be conducting KT activities, it's important to acknowledge the bigger system in which science is situated in. And with science being the vehicle to understanding our world better, more specifically in our instance, understanding the brain, it's commonly perceived that with each new finding, we are slowly chipping away, or rather adding to kind of this greater knowledge bubble. And with that, we must effectively capture new knowledge and ensure that it's appropriately lends to bridging this gap between what we know and what we do. So KT is effective when it's placed within an ecosystem of stakeholders. And you can kind of see some of the various players there on the left. And this is to make progress a reality, and it's our job as science managers to oversee this network of people to ensure that they all work in synergy. Having the ability to discern between the roles and incentives of this integrated network of science stakeholders is key, and who listens to who and what is convincing. So is it that we have the evidence, or do we need the expertise or stories? And all of these kind of play a role in being successful with knowledge translation, which I think also goes nicely to the next topic of science communication. And with that, I'd ask, why do I want to talk to people? So the obvious one is that you want to share your research, but also to find collaborators or funders, or perhaps recruit new lab managers. And who should you be talking to? Obviously your colleagues, those in neuroscience, but also those outside of your own discipline. A large focus of my work is to remove those barriers that keep us in our silos, whereby we can really be encouraged to have more open conversation and cultivate a dialogue in a more multidisciplinary setting. Also funders and investors, both secured and potential. And a big one also related to knowledge translation is the public. Having people care about your work not only makes it more meaningful, but it also has a downstream effect on policy and decisions. And also to be reminded that to take a step back and assess things, not just for what they are now, but a little bit more future focused. And when it comes to outreach, this is something that some of us begrudge.
Can I ask you to wrap up?
Sure. So I'll skip this one. I'll just say that this is people and performance management is also very important. And I'll skip that too. And Gantt charts, I mentioned them earlier, friend and enemy, but using them can be very useful. And ways forward, I would just like to say that developing your own science management toolkit as per your own needs is key. And if you can't do it, hire a lab manager. And if you're working on a larger research program or project, hire a project manager or program manager. And there are funding agencies that are starting to support these things. And I'm starting up a new group called the Science Management Collective, where we'll be working on such issues as this to really build out some standards and best practices within the field of science management. So thank you, and happy to take any questions if we have time.
Thank you, Tanya.